In this video, we're going to do a couple more questions with logic laws. So for the first one, we want to show that P arrow Q and not Q arrow not P are logically equivalent. We don't want to use truth tables, and we don't want to assume that they are logically equivalent. So how do you approach this? Well, of course, the first thing we're going to do is we're going to start with P arrow Q. This is our assumption. And then the second part, we're going to use the definition of the arrow. So what is the definition of the arrow? Well, this says if we have P arrow Q, this is equivalent to not Q, or sorry, this is equivalent to not P or Q. Okay, so now for the third, I'm going to use the commutative law to switch the order of these. So this would be Q or not P. Then for the fourth, I'm going to use the definition of the arrow yet again, and we'll switch this into not Q, arrow, not P. So if I was being really rigorous, what I would do is I would introduce double negation here, but we'll just take it for granted. So this is how we use the definition to get to the contrapositive law and to show that P arrow Q is equal to not Q arrow not P. Okay, second one, we want to show that P arrow R and Q arrow R is equivalent to P or Q arrow R. So we could take and we could make this an arrow, and we could show this is a tautology between these two well-formed formula, but instead I'm just going to reduce the first statement to the second statement. So first, we're going to have our assumption. This is P arrow R and Q arrow R. We're going to use the definition of the arrow again on both of these. So we're going to get not P or R and not Q or R. So this is the definition of the arrow. For the third one, well, we have an R that's common in both, so we can use the distributive law to take it out. So this is going to be the same thing as R or not Q and not P. Okay, so this is R or not Q and R or not P. So that's the distributive law. We're just using it backwards. For the fourth step, we are going to use the definition of the arrow. So for the first step, I'm actually going to switch the order here. So this is not Q and not P or R. So this is the commutative law. 5, I'm also going to stick the double negation in there. So for 5, we use the definition of the arrow. So we're going to get not Q and not P, arrow R. So this is the definition of the arrow. And then for our sixth step, we're going to use De Morgan's law, and we're going to distribute the not into the antecedent. So we're going to get not Q or not P. This will be arrow R. So that's De Morgan's. And then with the double negation law, we can just get rid of the two negations in front of Q and in front of P, and we get Q or P arrow R, which is exactly what we wanted to find in the first place. So we have proven that these two statements are logically equivalent. So that's it for logic laws. If you have any other questions, please leave them in the comments below, and I'll answer them the best that I can.